Howdy folks. In this video, I'm going to explain how to solve a system of equations by a technique called substitution. Okay? I've already told you that there's a few ways that you can solve a system of equations, and this one is called substitution. Now I have the procedure written out over here in steps, so if you want to write these down, that could be helpful. Or we'll just walk right through them. And what we're going to do is, here's a system of equations, and we're going to use these steps. We're going to read through these steps to solve this system of equations. Now, let me remind you that when solving a system of equations, what you're trying to do is you are trying to find a value, one specific value for the y variable and one specific value for the x variable, and that's assuming it's a system of linear equations. That is, the y is to the first power and the x is to the first power. Okay. Also, I wanted to, what was I going to say? I wanted to remind you that I had mentioned in a previous video when we were learning about solving linear equations, one of the things that I had told you is that you can only solve a system if you have a number of equations equal to the number of variables. And you'll see that in this equation there are two variables, and in this equation there are two different variables, right? So in order to have a solution, a very specific solution, you would have to then have two equations. And in this case, we do have two equations. We have this equation and we have this equation. So we can solve here, okay? So let's go here. Let's look at our first step. Step one, solve for x or y. That means you have to choose. Solve for x or y in one of the equations. So we either have to solve for x or solve for y in this equation, or we have to solve for x or solve for y in this equation. Well, it looks to me like this one, this upper one, is going to be the easiest one because there's a 1 in front of the y already. It's a negative 1, but it seems like it would be easier to solve, where here, to cancel the 7, I'd have to divide by 7, and that'll make this 3/7. I don't want that. To solve for y in this bottom one, I'd have to divide by 3, and that means I'd have to divide by 3 over here, and that would give me 7/3, and I really don't want to deal with a fraction. If I can avoid dealing with fractions in this solution, I want to avoid it. So I'm only going to try and solve in a situation where I won't have to deal a fraction. So here I can divide by -1 to get rid of that negative, and so I'm going to stick with the top equation. So I'm going to go over here to the side, and I'm going to write 4 minus y is equal to 3x. And so I can subtract 4 from both sides, and what I get is, excuse me, almost wrote 4x, cancel the 4, and I get negative y is equal to 3x minus 4. Now, this does not say solve for negative x or negative y in one of the equations. It says solve for x or y. Well, this is not y, this is negative y. So I need to multiply by -1 or divide by -1, that's fine too. Well, -1 times negative y is y equals -1 times 3x is negative 3x, and -1 times -4, that's positive 4. So I have successfully completed step 1. I have solved for y. And what is y equal to? Y is equal to this package right here. This is all one thing. It's -3x plus 4. -3x plus 4. Which, remember that. I'm putting it in parentheses on purpose because what we're going to do is we're going to take that -3x plus 4 package and we're going to move it into one of the two equations. Actually, we're moving it into the other equation. See this? Plug the other side of that equation, the equation from step 1. This is y, this is the other side. Plug the other side of that equation in replacement for the variable. Okay, that's the variable from step 1. This is the variable y. We're going to replace the y in the other equation. So let's take the other equation. That's 7x minus 4 is equal to 3y. And here's what we're going to do. I want to show you something here. I'm going to do y in a different color here. 7x minus 4 equals 3y. Y, well, what is y equal to? See this red y and this red y? They're the same, right? And y is equal to this thing right here. So what I can do is I can take this y out and I can put this expression in where the y is. When you do that in math, that's called substituting. You are substituting the y out, and you're substituting the negative 3x plus 4 in. So I'm now going to have 7x minus 4 is equal to 3, and then what I would have here is y, but instead of the letter y, I'm going to put in what y is equal to, which is negative 3x plus 4. So I'll put a negative 3x plus 4 right there. Next step says solve for the remaining variable. See, says so that there is only one variable remaining. Look, the only thing left in this is an x. There's no more y. So we can solve for the remaining variable. We have one equation, one variable, we can solve. So I've got 7x minus 4 equals, I'll distribute this 3. 3 times negative 3x is negative 9x. 3 times 4 is positive 12. Now I'll add 9x to both sides, and that cancels over here, and then I get 16x minus 4 equals 12. Now I'll add 4 to both sides, cancel, and I get 16x equals 12 plus 4 is 16. Divide by 16 on both sides, and I get x is equal to 1. So I have a solution for x, I have a value for x. Step 4 says plug the solution from step 3. Well, this is my solution from step 3. Into one of the equations that we started with and solve for the other variable. The other variable would be y. Now, one of the things you can do is you can actually go back up to your y equals solution, and you can use that. So I'm going to bring down y is equal to negative 3x plus 4. Well, I'm going to put this x equals 1 in here. So I'm going to have y equals negative 3 times 1 plus 4. And so y is equal to negative 3 times 1 is negative 3 plus 4. And negative 3 plus 4 is 1. So I have a solution for y. So the answer is x equals 1 and y equals 1. Now, when you get a solution for a system of equations, you can take those answers, and if you want to check to make sure the answer is correct, you can take those answers and you can plug them back into both of the equations to make sure that they check out. So if I put a 1 in here and a 1 in here, I'd have 4 minus 1, that's 3, equals 3 times 1, which is also 3, so it does check out. But let's make sure it checks out in both equations. Let's put a 1 here. 7 times 1 is 1, or excuse me, 7 times 1 is 7. 7 minus 4 is 3. And over here equals 3 times 1. Well, 3 times 1 is 3, so it does check out. And so we have a successful solution for this system of equations. Let's try another substitution problem. All right, here is another substitution problem. And so if you want to, you can pause the video and try it on your own, or you can just watch me work through it if you want a little more practice. All right, let's see if you got it right in case you tried it out. The first one says solve for x or y in one of the equations. Well, this one already has, look at this, this one already has a 1x. So this is almost set up. This is almost ready for step 1. I just need to add 1 to both sides. And so that's going to give me x is equal to 7y plus 1. So I have my x is equal to. So now step 2 says plug the other side of that equation, that means this side, the 7y plus 1, in replacement for the variable x in the other equation. So see this one up here, this 4y plus 3x equals negative 22. I want to replace that x right there with this 7y plus 1. So I'm going to bring down 4y plus 3x, there would be an x here, is equal to negative 22. But instead of putting an x here, I'm going to put what x is equal to, which is 7y plus 1. 7y plus 1. Now, step 3, solve for the remaining variable. Look, there's only one variable in this equation, only y. Now you may say, Mr. Ryan, there's 2 variables in there. I see 2 letter y's. Well, what I'm telling you is we're going to combine those. So that's really only one variable. So this, we're going to distribute the 3, and we get 4y plus 3 times 7y is 21y. 3 times 1 is 3 equals negative 22. 4y plus 21y, that's 25y. Then we're plus 3 equals negative 22. Now we're going to subtract 3 from both sides. And we get 25y is equal to negative 22 minus 3 is negative 25. We'll divide by 25 on both sides. And what we get is y is equal to negative 1. So we have a solution for y. That was step 3. Now we're going to go to step 4. We're going to let's take this x equals 7y plus 1. X is equal to 7y plus 1. And we're going to plug the solution from step 3, which is negative 1, into this equation for y. So we're going to go x is equal to 7 times negative 1 plus 1. X equals 7 times negative 1 is negative 7 plus 1. And x equals negative 7 plus 1 is negative 6. So now we have a solution for x. And we can now take these two solutions and we can plug them into the original equations and make sure that they're correct. If we put a negative 6 here, negative 6 minus 1 is negative 7. 7 times negative 1 is also negative 7, so we're good. If we go to this one, put a negative 1 here, 4 times negative 1, that's negative 4. Plus 3 times negative 6. 3 times negative 6 is negative 18, so it's negative 4 minus 18 equals negative 22. Sure enough, negative 4 minus 18 is negative 22. And so this system of equation checks out. These are the correct solutions for x and y. Let's try another example. Okay, here's another system of equations. Why don't you try to solve this by substitution? Pause the video and give it a shot. Okay, now I'm going to do my solution. Now I see this one up here. This has a negative x or negative 1x. This one's there's too many numbers in front of these other letters. So I think I'm going to solve for x up here. So if I have 3y equals 5 minus x, watch what I'm going to do. I'm going to add x to both sides. And now I'm going to have, that's going to cancel over here, and I'm going to have x plus 3y equals 5. Then I'm going to subtract 3y from both sides. That'll cancel the 3y, and I have x equals 5 minus 3y. So now I have my solution for x. I'm going to put parentheses around this. And then I'm going to carry down the other equation. I have 4, and then I'm going to put parentheses. 4 times x minus 3y is equal to 20. And in the place of x, I'm going to substitute what x is equal to, which is 5 minus 3y. So I'm going to put 5 minus 3y right here. And now I'm going to solve for y. 4 times 5 is 20. 4 times negative 3y is negative 12y. Minus 3y is equal to 20. I'm going to combine like terms here. So I'll have 20. Negative 12y minus 3y is negative 15y. And that is equal to 20. Now, I'm going to subtract 20 from both sides and cancel here. So I have negative 15y is equal to 20 minus 20, and that's 0. Now, right about now, when you were working on this, maybe you got a little bit of a heart attack. You're like, uh-oh, I don't know what to do now. There's a 0 in there. This actually makes it easier, not more difficult, because watch this. This means that y is equal to 0. Negative 15 times something is equal to 0. Well, the only thing that you can multiply by to get an answer of 0 is 0. Let me show you algebraically. We divide, what you would normally do is divide by negative 15, divide by negative 15, and what a lot of people have difficulty understanding is that 0 divided by any number, mostly, is 0. 0 divided by 1 is 0. 0 divided by 17 is 0. It's okay to have a 0 in the numerator. It's just not okay to have a 0 in the denominator. Okay? So 0 divided by negative 15, that's 0. And so we have a solution for y. Y is equal to 0. And it is okay for y to equal 0. It's also okay for x to equal 0. It's okay for both x and y to equal 0 at the same time. Okay, well, let's find out what the value of x is. Let's go up here to x equals 5 minus 3y. X equals 5 minus 3y. Well, what are we going to put in for y? Y is equal to 0, so I'm going to put a 0 in here. So we have x equals 5 minus 3 times 0 is 0, and that means that x is equal to 5. So we have a solution for x. We can plug them in. We can put a 5 here. 5 minus 5 is 0. 3 times 0 is 0, so we're good. Let's put it in here. 4 times 5, that's 20. 3 times 0 is 0. 20 minus 0 is equal to 20, and that's correct too. Okay? Let's do one more example. All right, let's do one more substitution problem. Here's a system of equations. Now this one has an extra thing in it that that I haven't shown you yet. But if you want to try and go ahead and solve this, struggle with it, wrestle with it a little bit. If you want a hint, I'll give you a hint on how to start. If you want to start now, pause, don't get the hint, and go ahead and try. Okay, if you want the hint before you start, solve for one of the variables in the bottom equation. Start with the bottom equation. That one's a little bit easier, okay? Try to do the solution. All right, let's see how you did. All right, so I'm going to actually start with the bottom solution here. I'm going to put 3y minus 12 is equal to 6x. That's a very ugly looking y, so let's fix that a little bit. There we go. 3y minus 12 is equal to 6x. Let me show you why this one's easier. See, up in this other equation, to solve for x, I'd have to divide by 5. But if I divide this by 5, I have 4 over 5, and I divide this by 5, I have 7 over 5. I have a bunch of fractions that I don't want. But in this equation, and if I solve for y here, I divide by 4, and I get 5 over 4 and 7 over 4. I don't want that. In this equation, if I divide by 6 to solve for x, I'll get negative 12 over 6, which is negative 2, and that's okay. But over here, I'd have 3 divided by 6, which is 1/2. I don't want a fraction. But if I solve for y here, if I divide by 3 here, 3 divided by 3 is 1, negative 12 divided by 3 is negative 4, and 6 divided by 3 is 2. So I won't have any fractions if I solve for y in this equation right here. So that's what I'm going to do. First, I'm going to add 12 to both sides. Add 12, cancel, and I get 3y is equal to 6x plus 12. Then I'm going to divide by 3 in all the terms, and I get y is equal to 6 divided by 3 is 2x plus 12 divided by 3 is 4. And now I have a solution for y. I can plug 2x plus 4 in for y. In the other equation, so if I bring down 7 plus 5x is equal to 4 times y, but instead of putting a y, I'm going to put what y is equal to, which is 2x plus 4. So I'll put a 2x plus 4 here. So I have 7 plus 5x is equal to 4 times 2, 4 times 4. 4 times 2 is 8x, or 2x, sorry, 4 times 2x. 4 times 2x is 8x. 4 times 4 is 16. Now, I can subtract 5x here and subtract 5x here. Cancel, carry down the 7. 8 minus 5x is 3x. Bring down the plus 16. Now I'm going to subtract 16 from both sides. It's going to cancel over here. Bring down the 3x. 7 minus 16 is negative 9. Now I'm going to divide by 3 on both sides, and I get x is equal to negative 3, because negative 9 divided by 3 is negative 3. And so I can reverse this. I personally just don't like having my x on the right side. So I'm going to reverse it and say as x is equal to negative 3. Okay? Now I'm going to take this y equals equation, and I'm going to say, oops, that's supposed to be a 2. I'm going to put a 2 here. And then for this x, I'll put in a negative 3 plus 4. So y is equal to 2 times negative 3 is negative 6 plus 4, and y is now equal to negative 2. So I have a solution. X is equal to negative 3, and y is equal to negative 2. And if you want to plug those in up there, you can do that and make sure you have the right solution. Okay? That's all I have for solving a system of equation by substitution.